Okay, LeetCode problem 1448. Count good nodes in binary tree. Given a binary tree root, a node X in the tree is named good if in the path from root to X there are no nodes with a value greater than X. Return the number of good nodes in the binary tree. Alright, so we have example 1. Root node is 3, 2 children, 1 and 4. 1 has 1 child, 3, 4 has 2 children, 1 and 5. And our output is 4. Okay. 4 nodes in blue are good. Root node 3 is always a good node. Okay, that's good to know. So that means a root node is always a good node. So we're going to start off at 1. Node 4. Node 4. 3, 4 is the maximum value in the path starting from the root. Okay, so this is 3, 4. Okay. Node 5, 3, 4, 5 is a max value in the path. Yep. 3, 1, 3, node 3, 3, 3, 1, 3 is a max value in its path. Okay. Still confused. Example 2. We have a root node of 3. 3 has a child, 1 child, 3, and then 3 has 2 children, 4 and he has 2 children, 4 and 2. So the root is always good. It only has 1 child, so that's always good. And I'm assuming 4 is greater than 2, so that is always good. So this is 3. So example 3, root is, there's only 1 node, and it's 1, so run is the root node, and then the root is always considered good. The number of nodes in the binary tree is in a range, okay, each node, okay. Okay, let's look at some discussion questions, because the only thoughts I have right now is the root node is good. If you think this is too easy, maybe you're already very good with trees. Nope, very hard. Should be marked as easy. Okay, these are discouraging. Not easy, not easier. These silly guys screaming. Okay. The path of a node test of greatness is surpass ancestors and good thou shall be. Okay, so this would be 5, 5, 8. So, and this would be 5. So it'll be 1, 2, 3. Easiest question if you're familiar with tree. Okay. Define a function that takes node and value as input. Return if not node. Calculate max val with input val and node val. Increase counter if node value is greater than max val. Call this function with left and right with max val. This is helpful. Thank you, Manish. So we need a function to take in our node and our value. So, and then we need to early exit. That's I believe what it's saying. Calculate max val with input val. Okay, so this is the function. We're passing in a value. And then node val is up here, so that's how we calculate our max val. So we're gonna need a variable for max val. We're gonna need a counter, increase counter if node value is greater than max val. Okay. Call this function with left. So recursion, I see, is gonna be a big deal with these DFS problems. For our tree problems, we're always gonna be using recursion. So if a node value is greater than all values in the path from the root to the itself, it is okay. So that's why 1. So this is 3, 4, 5, 3, 3, 4. Okay. So that was throwing me off too. I think this is gonna be helpful. From Manish. So we're gonna need a function to count how many good nodes we have. We're gonna need our max value. And we need to increase our count. So easiest thing we need to do is initialize the counter. We're gonna need a way to traverse. We're gonna need a stack of some kind, I think. How I miss my for loops and while loops. Oh no, we could use a while loop here. Okay. Let's get our stack first. We're gonna need a tuple. What is gonna be in our tuple? We're gonna have, I guess what we're passing in, we're working with tree nodes and then our int. Tree node, then int. So this is gonna be how we do our traversal. So we're gonna have a tuple of our node and then the biggest number we came across in that path. So where do we go from here? We need a function, right? Define a function that takes node and value as input, return if node, calculate max val if input val and node val, increase counter if node value is greater than max val, call this function with left and right. Yes, second thought, this sounds, I don't really like using a function in the function, even though we have to recursive. Ooh, dark mode. Okay. Let's try something else. So We have our count, we have our stack. We need to add our first number, because we know that the first number is always good. So if root, we can add that to our stack. So we're just going to be passing the root node, and then this will be our first number. So this will be our we need it to be our max number. Do I do a variable? Let's just do it here. Let's see what happens. Okay, so we got our, so this would be us adding a root node to our stack. Since root always good. Okay. And then let's see. This is where we'll loop, but it can't be an if for loop. So while our stack isn't empty, empty, empty. And then we want to negate it while it's not empty. So we have our stack, and we want to use it to loop. So we can do some popping and pushing. So let's do what else do we need? Okay. Okay, so we're popping the top node from our stack. So that will give us the current node, and then we can use that to get the maximum in that path so far. 3, 5, 4, 3, 4, 5. Okay, so we have this, and now we need to do a comparison, I guess, of the node's value. Node.val is greater than or equal to our max node, and we want to increase the count. Okay, that doesn't really help us, because then, okay, we probably need another variable to keep track of our max. Then we'll just compare our max node and then our node value. Now we can just now safely add our right and left. This is where we'll do our appending. Okay. Let's try and do the same for right side. Then we can just do a comparison. No, we don't need to do a comparison. We're returning. We can return our count, which will be here. Let's see. Compiler error. Instant method appended expects a single parameter of type node and the solution. Add a node to our section. Always good. Okay. What am I doing wrong? So our stack is empty array. Okay. I need to do this rather. This should fix that. Cannot find left and scope left side and the right side. That was a miracle. All right, now let's test and see if we have any good times, if it all passes or fails. What? All right, not I mean, it takes a while. 150 on the right side of the graph. There's people that got lower. That's crazy. Very efficient. Okay. So let us look at some solutions. Your last beat 40%. Okay. All right, guard let root. return 0. Okay, so this one uses two functions. It has a second function, get good nodes, passing in the root and the previous max, and then returning an int. Also doing an early return. It's initializing the count inside of the second. Okay, so count plus equals previous is less than or equal to root value. If it is, it's 1, or we don't increase it at all. I guess that's a very complicated way to write that. Let maxi equal the max of the previous. Okay, so that's what I was doing. But I was using the max node. This is using the previous max of root value. And then increasing the count, and then returning count. Okay, that one is a little bit too complicated for me. Okay, so I should have probably used the max method. This is also using a second function. Okay. All right. So that is problem 1448. Count good nodes in a binary tree.